Welcome to Hydrology Hub channel. Dear friend, today I am going to demonstrate 1D unsteady state flow modeling using the HEC RAS software. So first of all, we will open the HEC RAS window. We will go to the file, new project. Yes. We will give the name of the new project as suppose P3. Okay. And P3 we are giving. Okay. Now we'll go to the option, select the unit system as the metric unit system, so it is already there. Just click on the OK. Then next step is that we have to provide the geometry data. Just click on this geometry icon. There is a view of the edit geometric data. Just click over there. So this window, your geometry data window will open. So first of all, we will create a river reach. Just click here and create a river reach. Give the name of the reach. Suppose it's Ganga Canal. We have provided, and reach is 1. Okay. Give this one. Now we'll enter the cross section. So suppose the total canal length is 10 km and we are providing two cross section at 0 channage and at 10 km channage. 0 is my most downstream point and the 10,000 or the 10 km is the most upstream point. So at 0 channage I am providing the cross section. So it's a trapezoidal cross section. So at station 0, first of all, what we have to do, we have to create the option, go to the option, add a new cross section. So at new cross section at 0 channage will give. So at 0 cross section, now we'll enter the data. At 0 channage, my elevation is 10 meter. Now at 15 meter channage, my elevation is 0. Now at 25 meter channage, it's 0, means the bottom width of the channel is 10 meter, and then 40 meter channage, it's 10 meter. Okay. We can apply the data and see how the cross section is coming up. So this is the cross section is coming up. Now we'll provide other values of this cross section, like the Manning's values. So it's 0.025 for the left over bank. Now 0.025 for the channel and 0.025 for the right over bank. Okay. Now we'll provide the main channel bank stations. So main channel bank stations are, our left bank is 0 and the right bank it's 40. So it's 0 and 40. So these we have provided, and we will apply the data. So this data is being applied on this cross section. So what we will do, we will copy the same cross section at 10 km upstream. So we'll go to the option, copy this cross section at 10,000 meter. 10 km means 10,000 meter upstream. We have copied. Okay. Now we are considering that there is a 1 meter fall in the 10 km of the canal. So that means by 10,000 meter means the upstream cross section is 1 meter above what we have at the 0 channage. So what we will do here, we will go to the option, adjust the elevation to 1 meter and raise the elevation 1 meter at the 10,000 channage station. And again, now from 10,000, our downstream reach length is, it's 10 kilometers, so 10,000 will provide 10,000 and 10,000, and then apply the data. So now I have two cross sections in the canal, one at 0 and another one at 10,000. So 0 is the most downstream point and 10,000 is the most upstream point, and the length of the canal is 10 kilometers. Now I will interpolate cross section at every 1 kilometer interval in this canal. So I will go to the tool, just go to the XY interpolation, then within a reach we will just interpolate at every 1000 meter distance, interpolate cross sections, close. So now the cross section have been interpolated. You can see this cross section over there again. Open the cross section. Now you have all these interpolated cross sections over there. All cross section you can see, these are there. So now we have two cross section what we have provided, and the other cross section we have interpolated in the canal. So we'll save this data file, save geometry data at G, just we are going to name as G. Okay, close this window. Now we'll go to the unsteady state icon over there, view edit unsteady flow data, just click there. Now at 10,000 change means that the upstream point will provide the flow hydrograph. We'll just go to the flow hydrograph. Now this window will open to enter the flow hydrograph. So we'll first give the fixed start date. So suppose we are selecting as 1st September at 00 the flow is starting or the hydrograph is entering. So now here we will give at 0, at suppose at 10 meter, that is the highest peak of the hydrograph, it is 250 meters suppose, and at 2nd September means after 40 hours it just has the 0 values. So we'll go to the 2nd September, you can see here 2nd September at 16 hours it is coming as 0 again. Okay, now what we will do, we'll simply interpolate all the values in between. We'll just click on the interpolate. So here you can see this hydrograph over there. So it starts from the midnight of the 31st or the 1st September, and it ends at, you can see 2nd September at 4 p.m. it ends. Okay, so that your hydrograph is there. Now here you have to provide the slope. Okay, so here our slope is 0.0001, means 1 meter fall in 10 kilometers, means 1 upon 10,000. Okay, again at the most downstream point at 0 change we have to provide the another boundary condition, that is we will provide the normal depth that is equivalent to the slope of the channel 0.0001. Okay, we'll just save unsteady flow data. Flow data, you can give a flow data name. Okay, close this one. Now we'll go to the simulation icon here, unsteady state flow analysis icon. Just click this icon, and first of all, before we start simulation, we'll go to the option, click here stage and flow output condition. So we want to just select, we want output at each and every cross sections. So we select all the cross sections and take this cross section here. So that means we want result at each and every cross section. We'll just click OK. Now we'll select here. Okay, then we'll select the start date at 1st September. My hydrograph start on 1st September at 00 hours. And it ends on 2nd September 16:00 hours. Now here we will take the computation interval at 1 minute, and these all are at 1 hour, and compute. So now the simulation is taking place. It says that the complete process. Now the process is completed. Close this one. Okay, it is saved as plan 1. Okay, close this one. Now you can see the results. So each and every cross section you can see how much water depth is there. So you can just go on selecting each section. You can just see at every section what is the flow depth is there. You can just see here at each section flow of the how flow is changing over there. Okay, so you can see here. So all these things you can just see here. You can change the flow speed also, this speed also, and then you can just see how it is taking place. Okay, this you can manage all these flow speed, simulation speeds, or the plotting speed over there, animation speed you can change, and you can see how the flow water is changing. So here you just see initially, once I'll show you, we'll go back over there. Okay, so you can just play over there. So initially you see flow was 0 and it is increasing. So maximum flow has come over there because 250 was the maximum flow in the hydrograph, and it has reached, now it is decreasing. So initially it's a rising limb of the hydrograph, flow was increasing in the canal, and now it is decreasing. Okay, so this way you can just see each and every cross section how it is taking place. Similarly, you can see the profile also. I'll just close this one. You can see the profiles also. So how the profiles are there. So you can select various profiles. Okay, you can, from here you can just select various profiles and just see how they are there. Okay, at different times and other things you can just see. So this way you can interpret the results. Over there you can see the hydrograph also. Okay, at different section how the hydrographs are there. At different sections you can just see hydrograph, how the hydrographs is there. So this way, and you can just analyze the result in a tabular form also. So this way you can carry out the 1D unsteady state flow modeling using the HEC RAS. Thank you very much. If you like this channel, please subscribe it